Hello everyone. My name is Sai Kiran Reddy, and me and my friend Vamsi Krishna are going to handle knowledge representation. So before going into knowledge representation, let us discuss the importance of the knowledge representation. So what is knowledge representation? So early in the early centuries, early workers used to believe, especially in the artificial intelligence, experience has shown that intelligent systems such as cannot connect anything useful unless they contain a large amount of real world. So probably it could be domain specific or also domain related on the knowledge. So this is the analysis that have been done by the early workers in artificial intelligence, in the artificial systems. So humans are almost always tackle difficult real world problems by using the resources of knowledge such as experience and training. So humans are always tackle the difficult real world problems by using their experience and also the training. So this raises the problem of how knowledge can be represented inside a computer. So after describing the difficulties, so it has been always a problem to represent in the computer, so in such a way that AI program can manipulate it. So some knowledge representation formalisms have featured how to inculcate in the AI artificial intelligence in the system have been given below, and through which knowledge representation formalisms have been done. So there are three basically. So first one is production rules and formal logic and structured objects. So production rules, let us discuss it later, and formal logic, it is a language based on it. For example, it is example of formal logic is PROLOG, where we will discuss PROLOG code in the upcoming session. And next one is structured objects. In structured objects there are three: semantic nets, frames and scripts. So semantic nets are otherwise called as networks, frames which are dependent on the object oriented programming languages, and these are derived from the frames, and the other similar and also another similar object is known as scripts. So we have already examined production rules in some detail, so now we will look at some other formalisms. So knowledge representation using structured objects. Till now, as far as of now, we have discussed how knowledge is represented in the computer. Now we will discuss deeply about how knowledge is represented in the form of using structured objects. So structured objects are in structured objects, knowledge representation formalisms whose components are essentially similar to the nodes and arcs found in the graphs. So it is this knowledge representation in structured objects can be done through the help of nodes and arcs. In contrast to production, it follows the production rules in formal logic, where an attempt to incorporate certain desirable features of human memory organization into knowledge representations. These are helpful for the human memory organization, which are able to create a knowledge representations. So contents, we will discuss about the knowledge representation issues, semantic networks, frames and scripts. Semantic networks, frames and scripts are the structural objects. So knowledge representation issues. So knowledge representation issues. The major issues of the knowledge representation are: it becomes clear that particular knowledge representation models allow for more specific, more powerful problem solving mechanisms that operate on them. So examine specific techniques that can be used representing and manipulating knowledge within the hardware. So representation mapping is done through facts. Facts are in the sense truths in some relevant world. These are the things that we want to represent. So representations of facts in some chosen formalism. So things are actually manipulating. So structuring these entities is done at the two levels: the knowledge level and the agent level, and at which the knowledge level is a level at which concluding each agent's behavior and current goals are described. And this is the process of understanding the English example of understanding the English understanding generation. This is the internal storage, and this is an external storage, and this is something that we try to understand the recurrence conclusion algorithm. So approaches. So there are basically many approaches for the knowledge representation. Some of the approaches are knowledge representational adequacy, the ability to represent all the kinds of knowledge that are needed in that domain. So it is nothing but the ability to inculcate the kinds of knowledge that are specifically mentioned in that particular domain. The second approach would be inferential adequacy. It means that it is the ability to manipulate the representation structures in such a way that it derives the new corresponding structures to new knowledge inferred from all. So the third one is inferential efficiency. Efficiency is nothing but the best or the best way to find the solution. So it does mean that the ability to incorporate into knowledge structural additional incorporation that can be used to focus on the attention of inference mechanism in the most promising directions. And the fourth one would be acquisition efficiency. It means the ability to acquire the new knowledge or the new information easily. It is the simplest case, involves direct insertion by a person of new knowledge into the database. It means that it is a process of inculcating in the database using the person of the new knowledge. Semantic networks. Semantic networks are nothing but a structure of representing knowledge as a pattern of interconnected nodes and arcs. It means that an example would be shown later, and it means it is a graphical representation of knowledge where with the help of graphs and with the help of nodes and arcs is done. It means that the objects under consideration serves as nodes and the relationships gives us the arcs. So the nodes are represented in the form of boxes and arcs are represented in the form of arrows. So nodes represent entities, attributes, states or events. Arcs in the network gives it gives the relationship between the nodes and labels, or the arcs specify what type of relationship it actually exists. Arcs specify whether it is a relationship, and it also shows inheritance. So now let us discuss about frames. Frames are nothing but it is a sense of knowledge. It is where the knowledge is organized into small packets called as frames. All frames in the given situation constitute the system. So a frame can be defined as a structure that has slots for various objects, and a collection of frames consists of expectation for the given situation. So frames are used to represent two types of knowledge, that is declarative or factual and procedural. Declarative and procedural frames. A frame that merely contains description about objects is called as a declarative type or factual situational frame. A frame that contains description, it means the description of object is contained in a frame which is called as a factual situational frame. For example, this is the name where a computer center describes about the name of the frame, and this is a AC stationary cupboard, computer and dumb terminals and printer, where each and every frame is having a slots where AC is one slot and stationary cupboard is another slot. So now let us discuss about more about the frames. So frames which are having procedural knowledge embedded in it are called as action procedural frames. The action frame from the following slots: actor slot, which holds information who is performing about the activity; source slot, which holds the information from where the action has to begin; destination slot holds the information about the place where the action has to end; task slot, this generates the necessary subframes required to perform the operation, which means that it performs the necessary tasks to generate a necessary subframes. We will look at in the table, where a name is cleaning the act of carburetor, and the actor here expert and object, a source, destination, and scooter. This is the task 1, task 2 and task 3, and remove carburetor, which is another frame with clean nozzle and fix carburetor. These are the different frames in which use it to for the actors, which is an actor slot, and this is a source slot, and this is this last one is a destination slot, and this is a task slot. Let us discuss about the scripts, where a script is a mechanism for representing knowledge about common sequences of the events. A script is a structure that describes a stereotyped sequence of events in a particular content consists of slots. It contains values or also called as default values. There are many components of a script such as entry conditions, result, props, rules, track and scenes. Entry conditions are the events which are described in the script, and result conditions will generally be true after the events described in the script have been occurred. Props, these are the slots representing objects that are involved in the object or event described in the script. So roles are the slots representing people who are involved in the events described in the script. The track is nothing but a specific variation or a more general pattern that is represented, and the scenes are the actual sequences of the events that occur. This is a pseudo form of a restaurant script, a basic example where a script is given as going to a restaurant. Props, the properties in the restaurant would be food, tables, menu and money, and the roles are owner, or there will be many roles such as owner, customer, waiter, cashier. These are the entry conditions. Customer is hungry, so entry conditions would be where the customer will be hungry, and customer will be having money, and owner will be having the food. This is one. And the results of these is customer is hungry, owner has more money, and customer has less money, owner has less food. It means that after eating, the customer's hungriness will be gone, and owner will be getting money from the customer, and customer will be losing money after eating the food, and the food will be decreasing after eating the food from the owner. And this is another scene where entering a restaurant, and the customer enters the restaurant, where the scenes, the tables chooses where the customer chooses the best table and decides to sit and go there and occupies the seat. Second scene would be ordering the food, and customer will be asking them for the menu, and waiter brings it. Customer glances it, chooses what to eat, orders them item. Eating the food, waiter brings the food and the customer eats it. So now let us discuss about the knowledge representation using structured objects. It is being derived by the Cullian in 1968 as a model of human memory. This is a technique that has been offered that computers might be made to use words in something like as a human we did, and it is a failure of early machine translators and organization of semantic nets. It is a basic example that is being given here, where these are the boxes which represent the nodes, and these are the arrows which represent the inheritance, which is a relationship as it is being mentioned here, where animal is covered with the skin, where a bird is an animal and a fish is an animal, and the fish travels by swimming, and there are many other birds. For example, is ostrich is a bird, where ostrich travels by walking, and penguin is a bird which travels by walking. Penguin is a bird, and opus is an instance of penguin. Canary is yellow in color, and robin is red in color, and canary's Tweety is an instance of Tweety, and Tweety is white in color, where each and every bird is covered by feathers, and bird travels by flying, and fish does the swimming. And this is just an example that is being stated, where the semantic nets is knowledge represented as a collection of concepts, where the nodes are boxes, and the arcs are represented as the relationship, whether it is easy relationship or a relationship. Easy relationship shows the inheritance of the properties. This permits, for example, there is a four-wheeler car which is a Ford Escort. This helps us to know about the four-wheeler which has semantic nets, and where inheritance provides us with the cognitive economy, but it also provides the storage and space for processing the time of the trade-offs. This means that if we adopt a technique which it will use less storage, and also it will not take longer time to find the answer to the question. This is the main advantage. And now my friend Vamsi Krishna will handle from here.
Hello guys, I'm Vamsi Krishna. I'm going to handle it from here. Semantic nets. Semantic nets should be make a distinction between types and tokens. This is why the diagram uses instance of arcs as well as is arcs. Individual instances of objects have a token node. Categories of objects have a type node. These are the difference between token node and type node. There is always at least one type node above a token node. The information needed to define an item is found attached to the type nodes above it. So far this is just a diagram, not a knowledge base, but it can be converted into a knowledge base. Semanticness can be converted into a knowledge base as shown above. And this is the semantic net program written in a small PROLOG. These are the code, and from this code we get that ostrich is a bird, penguin is a bird, like this, and we get the relations between two types. And what is color A? In here it take A color C. Then this is the code what is color A belongs to and covered by C. A is covered by what? Here the code explains how the A is covered by and where the A is covered by, and how from where it is covered by. And in this explains how the A travels from one place to one with another. This program written in PROLOG, which contains all the knowledge represented in the diagram above, together with the mechanism for finding information by inheritance and a rudimentary natural language interface. It can answer questions like, is Tweety an animal? Yes. What color is Tweety? It answers as white. Opposite is covered by what? It answers as so on. It can answer many questions based on the diagrams and the code we have given. It can be written in C++ or Java. Although it is much harder in Java, it can write that in Java also, and any other present high level language. Note that I do not expect you to understand the details of the program or to mesmerize it or to be able to quote it. It is simply that to indicate that it is possible to store common sense knowledge like this, and it may not even occasions be quite easy. Problems with semantic nets. There are many problems with semantic nets. Some of them are logical inadequacy, vagueness about what types and tokens really mean. These are and heuristic inadequacy. Finding a specific piece of information could be chronically inefficient. It's hard to find a piece of information. Try to establish negation is likely to lead to a combinatorial explosion. Spreading activation such is very inefficient because it is knowledge gated. These are the problems we face with our semantic nets, and this can be avoided by attempting the following improvements: building such heuristics into the network so we can avoid such problems; more sophisticated logical structure involving parentializing. These improvements mean that the formalism's original simplicity was lost. These are the improvements we can attempt to reduce the problems in semantic nets. Developments of the semantic nets idea. Psychological research into whether human memory really was organized in this way, used in the knowledge bases in certain expert systems. Example: prospector. Special purpose languages have been written to express knowledge in semantic nets. These are the developments in semantic nets ideas. Psychological research can be done used in knowledge bases, and special purpose languages can be written to express knowledge in semantic nets. Thank you. These are our project, and thank you.
Voice clear.